On problem 1.1.31, told from the graph of the function, state the domain, the range, the intervals in which the function is increasing, decreasing, or constant. Complete parts A and B. So we have two different graphs. We'll do one at a time. So the first thing we're looking for is the domain, and we're going to want to write these in interval notation. So we have a linear function that goes forever down and left and forever up and right. So x values can be anything. So my domain is going to be negative infinity as my minimum and positive infinity as my maximum. Now the range, kind of the same idea we already mentioned. It's going to go up forever and down forever. So my range is also negative infinity to positive infinity. After domain and range, we're looking for when the function is increasing, decreasing, or constant. All right, so we are going to read left to right. So we're going to start on the left part of this graph here, and we are going to move to the right. Now, when I trace this, all I'm ever doing is increasing to the right side. So the question, what are the intervals when it is increasing? We're looking at the x values here. This graph is always increasing. So it's increasing from negative infinity to positive infinity. When is it decreasing? It's never decreasing. All right, it never goes down left to right. And when is it constant? It is never constant. Okay, so let's take a look at part B. So part B, now we have a parabola. All right, it's going to be upside down here, so this has been reflected. So my domain, it looks like it goes forever left and forever right. So my domain, negative infinity to positive infinity. Now my range, let's change colors here. There's a kind of a maximum value for my range up here. It only goes up to 1. All right, it doesn't go above that. So my range, let's start with the minimum. It goes down forever, so that's going to be negative infinity. However, it does cap out. There's a maximum value, and that value is going to be 1. It does look like it touches that 1, so we're going to say is we're going to put a bracket there. All right, my range does go up to 1. Again, that was the limit right there. Now, increasing. All right, so let's take a look at increasing. So again, left to right, we're going to start here, and we're going to go up. We're going to trace as long as this graph goes up. Now, when I get to this value here, where x is 0, because we're right along the y-axis, that's where my graph is going to change directions. So my value, or my function, is increasing from negative infinity all the way up until I get to this. Be careful, we're looking at x values when we're talking about increasing, decreasing. So the x value is actually 0. At that point, so when we do get to this point here, right at that point, we're changing direction. So it's not increasing any longer at 0, 1. So we're going to put a parenthesis here because, again, it's no longer increasing. So this half over here was increasing. Now, decreasing. Well, if the graph increases to 0 at the point 0, 1, that means it's got to change, right? So if it's changing direction and it's now going down, that means it is decreasing. It is decreasing from the point 0. Again, we're looking at x values. So this coordinate point is 0, 1. We care about the 0. And it's going to decrease forever. It's going to go down to infinity, or positive infinity. Now, what about constant? All right, what's going on here with constant? Well, this graph on the left side increases, and then once it gets to that point, it decreases. It never flattens out. Right? As soon as it stops increasing, it starts decreasing. So when is this constant? This graph is never a constant. Remember that increasing means going up left to right, and decreasing means going down left to right. Constant, I've mentioned this before, but constant would be if your graph was going up and then flattened out, or maybe went down and flattened out, or you just had a graph that was completely flat left to right. Okay, but it has to be horizontal at some point for it to be constant.